Welcome you all. Today we are going to deal about the branches of geology. Geology is relatively recent subject. In addition to its core branches, advances in geology in allied fields have led to specified sciences like geophysics, geochemistry, geohydrology, seismology, oceanography, rock mechanics, photogeology, and remote sensing. Similarly, based on the applied importance of geology in other fields related to subjects such as engineering geology, mining geology, and so on come to existence. The vast subject of geology has been subjected into two main headings. Under the main branches, we deal about physical geology, mineralogy, petrology, structural geology, stratigraphy, paleontology, and economic geology. Under allied branches, the dealings are about engineering geology, mining geology, geophysics, geohydrology, and geochemistry. Physical geology is variously described as dynamic geology, geomorphology, etc. As the name suggests, it deals with the different physical features of the earth, such as mountains, plateaus, valleys, rivers, lakes, glaciers, and volcanoes, in terms of their origin and development. The different changes occurring on the Earth's surface, like marine transgression, marine regression, formation and disappearance of rivers, springs, and lakes. Geological work of wind, glaciers, rivers, oceans, groundwater, and their role is constantly molding the Earth's surface features. Natural phenomena like landslide, earthquakes, and weathering. The main cause of surface changes is weathering. This is natural phenomenon resulting directly or indirectly due to change in the atmosphere. It is disintegrates and decompose rocks. These aspects of special importance from civil engineering point of view because of color, appearance, strength, and durability of rocks are adversely affected by weathering process. Thus, even granite, which is considered ideal for most of the civil engineering works like dam, become big and friable a thorough weathering, rendering it useless. Civil engineers deal with structures like dams, which are artificial barriers to the natural flow of rivers. Proper understanding of geological work of river and its features will lead to their utilization for civil engineering applications. Mineralogy deals with the study of minerals. Minerals are basic units with the different rocks and ores of the earth are made of. Details of mode of formation, composition, occurrence, types, association, properties, uses, etc. of minerals from the subject matter of mineralogy. Knowledge in this branch of geology is necessary for a civil engineer because the properties of rocks are to a large extent contributed by the properties and the composition of the constitutional minerals. For example, sometimes quartzite and marble resemble one another in sign, color, and appearance, while marble disintegrates and decomposes in a shorter period because of its minerals composition and properties. Petrology deals with the study of rocks, that is, rock sites. The earth crust, also called lithosphere, which is made up of different types of rocks. Hence, petrology deals with the mode of formation, structure, texture, composition, occurrence, and types of rocks. The composition and textural characteristics of rocks primarily contribute to their inherent strength and durability. Rocks based on their stability can be used as foundation for dams, for tunnel, and as minerals of construction. Hence, this is the most important branch of geology from the civil engineering point of view. The stocks which form the earth crust undergo various deformations, dislocations, and disturbances under the influence of tectonic forces. The result is the occurrence of different geological structures like fold, fault, joint, and unconformities in rocks. The details of mode of formation, causes, types, classification, importance, etc. of these geological structures form the subject point of view of structural geology. Civil engineering point of view, it is most important as petrology, since these geological structures modify the inherent physical characteristics of rocks, rendering them more suitable or unsuitable for civil engineering purposes. For example, a dam site, sedimentary rocks with upstream depth provide a desirable geological setup, while provide the same rock with the downstream depth make the geological setup most unsuitable. The study of the earth history through the sedimentary rock is called historical geology. The earth's surface is always uneven and provided suitable conditions for deposition of sediments of some place or the other. Therefore, there are the sedimentary rocks on the earth representing the entire period of the earth history. Proper investigations of these rocks reveal the chronological sequence of formation of rocks, evolution, mitigation, extinction deals of different plant and animal life during the different periods of the earth history. In addition, the climatic and geological changes, including tectonic events in the geological past, also be known from these investigations. It is also called stratigraphy. This is a massive branch of geology. It is not very relevant except for the fact that older rocks are in general more stable and more competent due to more compaction and cementation. Further, study of stratigraphy can be utilized in providing data which may be very important in some specific civil engineering constructions. Relics and remnants of ancient life preserved in rocks by natural process are known as fossils. Paleontology deals about the mode of formation of fossils, the types, occurrence, etc. from the subject matter of paleontology. If under favorable conditions, animal or plant life embedded in sediments, it will be preserved partly or completely. Similar to stratigraphy, paleontology is also an important branch of geology, though it is not of much importance from civil engineering point of view. But as fossils are rare and throw much light on the past history of the earth, civil engineer should know some details regarding them so that he recognizes them as fossils. Minerals can be grouped in general rock forming minerals and economic minerals. Some of the economic minerals like talc, graphite, mica, asbestos, gypsum, diamond, and gems are useful as such as raw materials in different industries. Some others such as hematite, gromite, galena, pyrolusite are used as ores from the extraction of various metals. The prosperity of nation depends on a large extent of rich reserves of economic mineral deposits it has. Example, Gulf countries are rich because of their oil deposits. South America, South Africa is rich because of gold and diamond deposits. The details of their mode of formation, occurrence, classification, association varieties, concentration, properties, uses, etc. from the subject matter of economic geology. This branch of geology, though it is very important by virtue of its economic importance, it is more relevant for civil engineers for obvious reasons. It will be enough for them to know a few details, as in the case of fossils, so that they will not be ignorant of them as and they come across this course of their civil engineering works like tunneling and road cutting. Each of the foregoing branches deals with specific subject matters and comprises the main branches of geology. Further, based on application of geological knowledge in the field, there are many other allied branches collectively called earth science. Some of them are engineering geology, mining geology, geophysics, geochemistry, and geohydrology. Engineering geology deals with the application of geological knowledge in the field of civil engineering for execution of safe, stable, and economic constructions like dam, bridges, and tunnels. It is particularly applied to the design, construction, and performance aspects of engineering structures in civil engineering. Mining geology deals with the application of geological knowledge in the field of Mining. A mining engineer is interested in the mode and the extent of occurrence of ores, their association properties, etc. It is also necessary to know other physical parameters such as depth, thickness, and reserve of the bodies of efficient utilization. Such details of mineral exploration, estimation, and exploration are deals with mining geology. The importance of geology in mining can be cited with examples. Sometimes the lodes or seams of economic minerals suddenly terminated. This might happen either due to top of the natural limit of the ore body or due to faulting. Geological studies will solve these problems, and if it is due to faulting, the continuity can be traced by ascertaining the direction and extent of displacement caused by faulting. The geological knowledge helps in planning the method of mining, a quarrying, a deposition, and advantageous way. The study of physical properties like density, magnetism of the earth or its parts to know its interest form the subject matter of geophysics. Broadly, it is subdivided into general geophysics or exploration geophysics. Pure geophysics deals with the general aspects of the earth as a whole, and exploration geophysics deals with the study of upper layer of the earth crust in order to solve some civil engineering problems. For example, to solve some civil engineering problems, to locate oil and gas deposits, locate groundwater, and exploring. There are different types of geophysical investigations based on the physical property utilized. Electrical methods, gravity methods, seismic methods, and magnetic methods. Engineering geophysics is a branch of exploration of geophysics which aim at solving civil engineering problems by interpreting subsurface geology of the areas concerned. Geophysical investigations are very useful to help solve foundation problems, alignment of structures, leakage problems along canals, locating building materials like stone. Electrical resistivity methods and seismic refraction methods are commonly used in solving civil